Hey, welcome to Module 1 of ECE 495, Fundamentals of Robotics Research. Today we're going to be going a little bit deeper into introduction of ROS. We talked about a little bit in big picture of why it's important, why we're using the department, but today we're going to talk a little bit more about the fundamental concepts, some key terms. In the second video, we're going to go through and make sure you have an understanding of the operation of ROS, and we're going to do that through application. I'll be working through some examples. Hopefully you can follow along on your system. And then we're going to do kind of in-class exercise, building a chat client using ROS. It'll be very basic, so only one person talking to sending messages to another, but we'll expand on that throughout the first couple lessons. So let's get into the introduction. So we talked about ROS a little bit, the robotics operating system, and it's basically a flexible framework for writing robotic software. It doesn't have to be just robotic software. Colonel Neff was using ROS for his assistive technology research and will be going forward. So it's not just robotics, but in this course we're gonna look at it through robotics, and that's kind of what it was primarily developed for, but it's expanded a lot further than that. So it gives us a lot of tools and libraries that allow us to kind of create these complex and robust robotic systems without having to create everything from scratch. And it works for many platforms. We'll talk about how that kind of works out. But it's considered a meta operating system. So robotics operating system, but it still requires that you have an operating system such as Linux. So on the Raspberry Pis, you have Ubuntu, which is a version of Linux operating system, and ROS kind of builds on top of that. So you still have to have an operating system, but ROS provides some additional capability that will then interact with the computer and allow us to interact with other systems like sensors and actuators like motors. We use ROS because it provides some robust capability. So it's hard to, there's all these different systems out there, sensors, LiDARs, infrared sensors, GPS, motors, all kinds of different things. And if we wanted to use those, we'd have to create different software for each of those. What ROS kind of gives us the capability is allows researchers or other universities to build these ROS packages or libraries that allow us to kind of use them and build on them. So we don't have to build everything from scratch. We don't have to know exactly how the LiDAR what equations it's doing, because someone else has already done that. And so that's a really good capability for ROS. And it allows for collaboration. So for example, in the capstone, we've created a tool that allows us to write to the TI RSLK Max to drive it. And so now we're going to take that tool that Mike Garrick-D and Noah Diamond last year built, and we're going to use that in this course, and we don't have to build that from scratch. So it gives us that collaboration capability, and that software is out there, and we can use it. Other universities can use it, and we don't have to build everything from scratch, which is really nice. So that's kind of a big picture introduction. Let's talk about some topics. So for example, sorry, not topics, keywords, just some vocabulary. So the first one here we have is melodic. So melodic is just kind of like the distribution, the version of ROS. So it's the version of ROS that we're going to use in this class. And it's the 12th distribution release. So it's ROS has been around for a while now. In May, a new version just came out called Noetic. We're not going to use Noetic for a few reasons. One of them is that, like I said, it just came out in May, so it's typically good to allow software a couple, months or anywhere up to 6 months to a year even to become stable before switching over. Because it is a big process, and we don't know exactly what melodic or Noetic supports yet. We don't know if there are any bugs, stuff like that. So you don't want to jump on and be the first one trying to figure out if all these different libraries still work. You want someone else to do that for you. So we stick with what we know. And the 499s and Capstone have used melodic last year, so we're going to just stick with that so that everything kind of transitions smoothly, and we're still using that. All right, Catkin is the compiler that we're going to have for ROS. So if you took Comp Sci 210, you saw a compiler for C. This allows us to take our packages, compile them into the code that we need. Two things I want to note real quick though is that when doing research later on in the class, you might be looking at a tutorial, you might be following some kind of instructions of how to create a package or build a package from some tool that is out there already, and they might talk about ROS make and ROS create package. Those are old and we're not going to use those in this class. Instead, what you would use is something called catkin make, and then catkin create package. And we'll see an example of both of those here in the demo. But I just want to kind of call those out because if you look at some kind of tutorial or anything like that, you might see those ROS kind of tools. Those they still work, but they are no longer really supported, and catkin is the primary now. So just keep that in mind. It's nothing really important as of right now, but that is what we will be using. All right, the master. So now we're getting a little bit more detail. So the master is the kind of controller for the whole ROS network. It enables all components to communicate within the system. So what that means is you have on one of the Raspberry Pis, so you guys have two Raspberry Pis, one's connected to the robot, one's not. The one that's not connected to the robot will be hosting the master. And all that really means is it's going to facilitate communication between all the different nodes. So you can still have a system on that Raspberry Pi doing things, and we'll do that for sure. But really, you always need this master running so that the whole ROS network is operational. Packages are what software in ROS is organized into. So basically, we just take similar software and we organize it into a package. So you might have, for our system here, you have like a groundbot package. What that means is like everything that you want to operate through that groundbot would be in the package and organized together. So for a larger system, so for the capstone last year, robotics capstone, we had, you had the ground robot, you had the drone, and then you had the kind of master that's controlling all the GPS information. So we had three packages. We had the ground bot, we had the drone, and then we had the master, or not really master, the controller package, sorry. And so that kind of gives you that capability to organize software a little bit easier. So everything that was working with the ground robot was in the ground robot package. And it's nice too because you can have, say you have 10 ground robots. Well, you can still use a ground robot package, and each of those can use that package, and maybe they just have some, little things here and there, but they're still getting the functionality of that overall groundbot package. The package.xml is just kind of where we do documentation. So this will store information on who the author is. It will store information on what what dependencies does the package rely on. So it might rely on different other packages and stuff like that. We haven't been great at maintaining the package.xml in the capstone or research, so this is something I kind of want to take a little bit more attention to detail, and it just kind of helps to maintain that continuity over time of, who's, what does this do, what's the version, who maintains it, and all that good stuff, so that next semester or next year, someone picks this up and has a place to start. Now getting a little bit more detail, we have the nodes. So the nodes are the actual executable Python scripts. So for example, we have, say, that ground robot package. In that package, we would have multiple scripts, Python scripts, that allow us to communicate with the different sensors, actuators on that ground robot. So you might have a node that can that reads information from the LiDAR. You might have a node that tells the robot to drive. Then you might have a node that, for the gyroscope, and then maybe a fourth node just passing all that information to the master or the controller. So that's kind of what you can think of a node is you have your system, which is your package, and then you break that system into its subsystems. So you have your ground robot, and then your subsystems would be the different sensors or actuators on that. So, and then these nodes use ROS to communicate to each other. So let's just get a little picture going real quick. So you have your package, which might just be your ground bot. And then that package might have nodes. So you have a LiDAR node. And then you have your gyroscope, or really, yeah, let's just call it gyroscope for now. And then your drive node. And then maybe you have your, let's just say you have a controller on here. And all of these communicate, and we'll talk about how they communicate. But they might also communicate with, a master or another overall controller, like a system controller, that's telling it where to go. And that might have a node that's just kind of like, calculate destination. And then you can have communication between those as well. And all of those nodes communicate over what are called topics. So communication, topic is a communication medium, or you can think of it as a bus, like a data bus. And then nodes, that nodes use to communicate. So this topic that, the calculate destination, this could be a destination topic. And so the calculate destination node would send information to the robot, the controller probably, telling it, hey, here's where I want you to go. And what is sent over that topic is messages. So nodes communicate over topics by sending messages. So the publisher and subscriber idea is kind of what we use a lot to send those messages. So basic idea is the publisher writes a message to a topic, and the subscriber reads that message from a topic. So you have a publisher that is writing a message. My handwriting is getting horrendous. Bring it in a little bit. There we go. Subscriber then reads message. From the topic. So in our example right here, we have this calculate destination might be publishing the destination, the message, the message might be, X, Y, and Z coordinates. That's what the message is, and then the calculate destination node is publishing that destination, and then the controller is subscribing to it. So every time the calculate destination node wants to create a new, hey, go here, it publishes that location and just constantly sends that message to the topic, destination, and then the controller subscribes to that reading. Every time that's updated, the subscriber reads that information and does something. So you can set a duration, or sorry, a number of how often it's set. So you might be sending that every 10th of a second, etc. So that's kind of your publisher subscriber model. And then the services is a little bit different. It's called a request and response protocol, or server client. And this concept is basically the providing node or the server offers a service, which is some kind of string name. So you can call that destination, whatever. And the client then calls the service or requests information by sending a request. And then waiting for a reply. And so this allows us to send less information over the network. So for example, if I am moving from point A and point B, and I only care where I am at A and B, then when I'm at A, I can say, hey, where am I? I will, the robot's the client, it'll send a request, where am I? And then the provider, ROS node, will say, here you are. And then maybe the robot goes and then gets to B, and during that time, it's not requesting any information, but then once it gets to B, it wants to double check, hey, where am I? Okay, good to go. And so that allows us to send less information over the network. That's pretty much it for your general kind of terminology. We'll go and look at a demo. I'll have the demo posted as well. And here in section 2 goes through all the commands I will use during the demo. And that will kind of show setting up a package, setting up nodes, and all of this terminology you saw here. Hopefully